This is the last of our 3 graphs, and we want an equation for it. And just like before, we need a box, because the box gives us all the parameters: the amplitude, the period, the midline, the phase shift, the horizontal shift. And from all of that stuff, we can figure out the A, B, C's, and D's, and we can write the equation. Okay, so let's start finding a good box to capture one cycle of my graph. Now I'm looking at this and I'm thinking, all right, let's start here. And I got a box. Okay, now do you see any troubles with this box? I like it when it's on the y-axis because that means no phase shift. However, there is not a complete sine wave or not a complete cosine wave here. It's not a full cycle. That is a dilemma. Another dilemma is the starting point. I have a starting point. It looks like it might be here, but I'm not exactly sure. The graph doesn't have very much detail. Especially if you're looking at my lecture notes, the graph is a lot smaller and it's hard to see. I think it would be fair to start at positive 2, but we can't use this box because we don't have a full cycle here. So that's a problem. That means we're going to have to figure out what our box is with a shift. So we're going to have to use a horizontal shift. So I'm going to move the box back and I can see, all right, here is a shift. If I use this, I start at the bottom, go up, and end at the bottom. That's a full cycle now. But this, what's my starting x? That starting x would have to be right around there, and I'm not exactly sure. It's not -4. It's before the -4. So I have a problem with this box too. I'm not exactly sure where that start value is. So that doesn't look so good. Now, we do have a couple of nice x numbers. Here's one at 4, clearly a good number to end with. Over here is 16, another good number to end with. So if we wanted to work with that one, we could go from -16 over to 4. And there I have a definite start and a definite end. And if I look in the box, I have 2 complete cycles. So I have a cycle down and up and down. So it hits here and another cycle down and up and back down. So I have 2 cycles. Now finding the period with 2 cycles will just be a little extra work. I don't recommend that though. I recommend making 1 cycle. But if we did look at this, it starts at -16 and ends at 4. That is a length of 20 units. It's gone 20 units from -16 to 4. Well, if 2 cycles is 20 units, then 1 cycle has to be 10 units. So I'm going to back this box up and see if I can make 1 cycle right here. Now that also is not 100% clear. What is that point right there? What is that x number? But we have a pretty solid case that we can make that x number a -6. Because from here, -6 to 0 and 0 to 4 is 10 units. So that would be a period of 10 units. And we figured out that this one was 20 units from these 2 cycles. So that is a very solid conclusion we can make, that that starting point is -6. So I'm going to use this box here to come up with the equation of that wave. It's not the only box, but I wanted to have information that was really solid and clear and not make any assumptions about points. And so we have a good logical reason to say we're starting on x equals -6. So let's use that information now and figure out the equation of this graph based on that orange box. So first, midline. That's dead center, y equals 0. So we got a midline here. That makes that easy. That means vertical shift equals 0. Done. Let's find the amplitude. Amplitude is from the middle up to the top, which is 4 units. Okay, next, the period. All right, since we're saying that we're starting at 6, at x equals -6, and we're ending at x equals 4, what is the period? This is a little formula that'll help you, especially when the period is based on fractions of pi. It can be harder to calculate the period, but it is always going to be simply end minus start. And in this one, it's intuitive, but if you go the end, 4 minus -6, sure enough, you get 10. So remember that, end minus the start. The period is 10 units. These are whole number units, though, not fractions of pi in this case. Vertical shift, none. Amplitude, last thing is horizontal shift. Do we have a horizontal shift? Sometimes it'll be called phase shift, and we do. It's -6. Last thing is we need the wave. What wave is that? And the wave in this box is starting on the midline. It hits the midline again here and the midline again here. That wave is sine, except it went the wrong way. It went down. So this is a sine, but it has been reflected. So we'll have to remember the reflection part later when we get to the A. All right, I think we're ready to start. All of those parameters on the box tell us everything we need to know about this graph. So let's start our equation. Y equals A sine bx plus c plus d. And let's do some scratch work here. Amplitude is 4. So A is not 4 because of the reflection. A is -4. But that was one and done, real easy. It's not one and done. We're not done. But we had one easy one there. The D number equals 0 because there's no vertical shift. So now we have 2 of them finished. Next, period and horizontal shift. These are facts in this window, but they're not B and C's. The box doesn't tell us B and C. We always have to work for B and C. Period and B and C are related, but there's always a little bit of algebra involved in there. So I do know period. Wow, that period equals 2 pi over B. And my box, I can see the period is 10. And the formula says that 10 has to be equal to 2 pi over B. So here's what I meant by doing a little bit of work. I don't know what B is yet. I know the period is 10, but not the B. So I'm going to have to solve for B. That cancels. And I'm going to get 10B equals 2 pi. And then lastly, I'm almost there, divide by the 10. And so I get B equals pi fifths. 2 over 10 reduces to 1 pi, 1 times pi divided by 5. Okay, so I've got 3 of them. I've got the A and the D and the B. I need the C number. Now this time I do have a horizontal shift. C will come into play, and it's not 6. Okay, this is, I'm going to write that in red here. My start is -6, but C is not equal to -6. Now, if I put it in the factored form, that's different, but I don't have the factored form here. So I have to find the C. Let's see. So let's do the formula. Phase shift or horizontal shift equals -C over B. And the window tells me I start at -6. And the formula said -C over B, and B I calculated over here, so I'm plugging that one in. Now I need to get C by itself. Well, I'm going to times by -pi over 5 on both sides. The negatives cancel, the pi fifths cancel, and I'm going to get positive 6 pi over 5 equals my C number. So I had to do a little bit of fraction algebra there, but I got it. I've got all 4 parameters, and I'm done with the equation. I just have to plug it all in now. -4 sine of B, which is pi fifths x. C is positive plus 6 pi fifths, and D is 0. I don't need a D. Now let's think about what happened here with this positive. What does the positive mean? That means my start shifted to the left. And that's exactly where our yellow dot is. The yellow dot is a shift. It went over to the left side. And, but it's, C is not the shift number. The positive tells us we're shifting left, but C is not where we're at. Anyways, that equation will graph that, make this graph that we're given here. Okay, now study that. I have one more little thought for you. Newton will also use the factored form. And the factored form can be slightly simpler, and I don't mind if you use the factored form if you study that, but I'm going to change the color for that here. All right, so there's something about this form, the original form. I'm just kind of stuck on it. I like this form. And it's not the only way to do this, though. There is the factored form, and once you see Newton and how they explain it, you might like the way Newton explains it. The factored form is going to be A sine of B times x minus h plus d, where d is the vertical shift, A is the same, so A, D are the same. The outside changes. B is actually the same too. So if you're going to use the factored form, you still have to find B. So you're still going to have to find B for this form. But the shortcut on the factored form, if you've got a graph and you can read your graph, h is going to equal the starting point. So in this case, in the factored form, h equals -6. And so it cuts out a tiny bit of work because you don't have to find c if you're okay writing your equation as a factored form. So this problem that we just did would have been a is -4 still. Sine, we still have to find b, and we did. B was pi fifths times x, and then it's minus h. So h is -6. That's my start point. And so that's going to be minus -6, which is plus 6. Close the bracket, close the parenthesis on the factoring of x plus 6, and then close the bracket on the sine function. And then the d is 0. So we don't need a d number here. And the blue one is also an equivalent equation. And if you look at it carefully, you can see, oh, this is pi over 5. Pi over 5. If I multiply pi over 5 through and distribute it, it's going to get me the same equation. It's going to go pi fifths times 6, which is 6 pi fifths. It's going to go pi fifths times x, which is pi fifths x. So we're going to get the same outcome either way, but both equations are equivalent. So the blue equation's a little more awkward in that factored form, I think, but it's a little bit more simple. So there's some trade-offs there. When you're studying in Newton, you'll see both ways. But I think Newton does a lot of their explaining in this particular way. But it's okay. I will take both on the written parts of the test. Anyways, study hard on this concept of taking a graph and writing its equation.